Okay guys, what I want to do right now is just go over something that you should already remember from Algebra 2, and that is right triangle trigonometry. As the name suggests, and as the picture suggests at the top of the page, we're going to be working with right triangles, and we know we have a right triangle when we see this little square in a corner that tells us that that is 90 degrees. You really can't assume that anything is 90 degrees unless you see that square. We have what we call right triangle ratios, and they're outlined here at the top of the page. You can see that the sine of some angle theta, and they're saying theta is this angle right here in the triangle, that is equal to the opposite side, which would be across from that angle, divided by the hypotenuse. Now the hypotenuse is always, always, always across from the 90 degrees. It's also always going to be your longest side. The hypotenuse never changes. Cosine of theta, that is equal to adjacent side. Adjacent side is the side that helps make the angle but isn't the hypotenuse. So the adjacent over hypotenuse, that's cosine of theta. Tangent of theta is the opposite over the adjacent side. So opposite again across from the angle. We just talked about adjacent. That gives you tangent of theta. Now the tricky thing can be if I were to say that this angle up here is theta, well then this side becomes opposite and this side becomes adjacent. So I have a little note about that. Remember, if we change the location of the angle we are working with, then the opposite and the adjacent sides change as well. How you label that triangle really depends on the angle that you're using. We have a little mnemonic device, something to help you remember these three formulas. You'll probably remember this from last year. The mnemonic device is SOHCAHTOA. It has a nice little ring to it. And at first when you look at those letters, you may not realize how they're helping you, but the SO part, the S stands for sine. So over here we have sine. Sine of some angle, we'll call it A. That is equal to OH. Okay, well that's opposite over hypotenuse. So hopefully now it makes sense where the O and the H are coming from. Cosine of angle A, remember A is just an angle. Well, we see the C here, that refers to the Ka part in SOHCAHTOA, so that is equal to A over H, which is adjacent over hypotenuse. And then the tangent of angle A, the T, means that we're going to be using the TOA part here, that's O over A, so opposite over adjacent. You don't have to use SOHCAHTOA to help you figure this all out. It's just, some people find it helpful. The downside is if you can't spell it right, then you might be in a little bit of trouble. Alright, so one of the basic things that you'll be asked to do is just find the value of different trig functions based upon a right triangle. Again, you cannot use these unless you have a right triangle. Sometimes people will start to use them all the time, but you can't do it all the time. You can only use them on right triangles. So I have sine of angle A. Here's angle A on the triangle. I know that sine of A is opposite over hypotenuse. Well, the opposite side would be the 20. The hypotenuse would be the 29. So that equals 20 over 29. And we can't reduce that fraction, so we'll leave it alone. Cosine of A, here's angle A. Cosine of A would be adjacent over hypotenuse. The adjacent side is 21. Hypotenuse is 29. Again, we can't reduce that. Tangent would be opposite over adjacent. Opposite is 20, adjacent is 21. And there you go. Now you can see on the other three over here, I have changed the angle that we are working with. That means the opposite and the adjacent sides change. Now I'm kind of thinking in terms of this angle up here. So I'm at this angle. I need sine of that angle. It's still opposite over hypotenuse, and actually the hypotenuse doesn't change. It never changes. That's going to be 29. The opposite side, though, is now 21. Cosine of B, it's still adjacent over hypotenuse, but adjacent is now 20, and that's 20 over 29. Tangent of angle B is opposite over adjacent, so that's going to be 21 over 20. Another thing that you're going to need to know about tomorrow is what is an angle of depression and an angle of elevation. Again, it's something that would have come up last year in Algebra 2. I just want to make sure that we're prepared for the word problems that we're going to see tomorrow. An angle of depression, by definition, is the angle formed between the line of sight and the horizontal. Ooh, actually, let's change that around. Line of sight, how about between the horizontal and the line of sight down to an object. And I want to stress, it's always formed with the horizontal. That's probably a big thing that people mess up. They sometimes draw their angle of depression with the vertical. It's always drawn with the horizontal. An angle of elevation is going to be very similar. It is the angle formed between the horizontal, so there's that horizontal again, and the line of sight up to an object. If you were in my Algebra 2 class last year, you may recognize this picture over here. I had this in your notes last year's too. So this kitten, let's say it's looking up at the balloons. Well, there's an angle of elevation from itself up to the balloons. Here's the horizontal, it's kind of like the ground. Okay, here's the kitten. If it looks up to the balloons, its line of sight is right here. Let's just pretend like its line of sight is from the feet. Sometimes that's not always the case, but this angle right here is your angle of elevation. We could also say that there's an angle of depression from the balloons down to the kitten. So here's the horizontal, it's kind of like the horizon. Line of sight down to the kitten. If balloons had eyes, it would look down this way. Your angle of elevation, angle of depression is right there. Now, hopefully you remember from geometry that these are, I believe, alternating interior angles, which makes them equal. So if you have an angle of elevation, you automatically know the angle of depression. Now, if you're wondering how this ties in, if I were to draw just an angle line straight down from either one of these objects, I will be forming a right triangle. Okay, so these two concepts are definitely going to be integrated tomorrow into some word problems. All right, and that's it.